In the beginning, our young sun was surrounded by a vast glowing disk of gas and dust. Inside this turbulent ring, trillions of tiny particles collided, merged, and slowly began to build the worlds that would one day orbit this star. Within this dusty chaos, one growing clump began to dominate. Each collision added mass and heat, turning this proto-Earth into a heavier, hotter body, slowly carving its own path through the swirling disk. As this young world grew, it was anything but calm. Countless asteroids and embryonic planets slammed into its surface, each impact releasing enough energy to melt rock, vaporize metal, and keep the entire globe seething with molten lava. Deep below the swirling disk, the surface of this forming Earth was a true hellscape. Gravitational compression, radioactive decay within its interior, and the constant rain of impacts all worked together to trap heat, turning what might have been oceans of water into global oceans of magma. At this stage, Earth was wrapped in global oceans of magma. From pole to pole, molten rock churned and glowed, a restless sea of fire where no solid continents and no liquid water could yet survive. Up close, these magma oceans were violently dynamic. Convection currents rolled through the molten rock, while bursts of gas and lava punched through the surface, constantly reshaping the landscape in waves of glowing, liquid stone. From these volcanoes, immense volumes of gas poured into the sky. Water vapor, carbon dioxide, nitrogen, and sulfur-rich fumes built a dense, toxic atmosphere, a thick blanket that trapped heat and kept Earth's surface locked in this fiery state for millions of years. In this early atmosphere, there was no free oxygen and no protective ozone layer. The air was a heavy greenhouse mix, more like modern Venus than present-day Earth, saturating the planet with heat and choking any possibility of familiar life. Under this heavy, toxic sky, Earth remained a world of fire. Only after countless eruptions and impacts would its surface begin to cool enough for the first fragile crust and, much later, true oceans to appear. For hundreds of millions of years, early Earth was under constant attack. Tens of thousands of asteroids and comets hammered its surface, turning impact basins into vast lava lakes and repeatedly rewriting the planet's outer skin. The largest impacts released unimaginable energy. In a single collision, entire regions of crust could be melted or vaporized, blasting glowing debris into orbit and feeding new magma oceans that spread across the battered surface. After each giant impact, enormous melt sheets spread out across the surface. These impact-generated magma pools buried older rocks, mixed deep material with shallow crust, and kept Earth's outer layers weak, hot and constantly being reprocessed. This extended barrage kept Earth's crust from ever fully settling. Repeated melting, burial, and mixing made it difficult for rigid plates or long-lived continents to form, but it also helped prepare the raw materials for the continents that would eventually emerge. For the first time, a solid skin began to form around the planet. This early oceanic crust was dark, dense basalt, a thin shell floating above the still molten mantle, stitched together by glowing fractures and young volcanic scars. This basaltic shell was thin and restless. Heat rising from below kept the crust fractured and mobile, opening new fissures, flooding them with magma, and constantly recycling the outer layers instead of letting them grow thick and stable. Along long volcanic seams resembling early mid-ocean ridges, magma rose from the mantle and spread outward, freezing into new basalt. These underwater rifts slowly pushed plates apart, building fresh crust while older sections moved away and cooled beneath the growing oceans. In a few places, parts of this basaltic crust melted at depth and rose again as more silica-rich magmas. The result was small, thicker patches of lighter rock proto-continents that stood higher than the surrounding seafloor and hinted at the continental crust that would one day dominate Earth's landmasses. Seen from above, early Earth's crust became a shifting mosaic. Dark basaltic plates, glowing volcanic seams, and scattered pockets of thicker, silica-rich rock. Over the next hundreds of millions of years, these small proto-continental fragments would collide, merge, and grow into the first true continents. By this time, Earth had oceans, but they lived under a heavy cloak of steam and volcanic haze. Dark waters rolled beneath dense clouds, while chains of fiery islands marked where magma still rose to the surface through a restless crust. As the planet cooled, water vapor condensed and fell as relentless rain. Storms could rage for millions of years, gradually filling basins and deepening oceans, while lightning and volcanic ash turned the sky into a chaotic, violent engine of the early water cycle. Where lava met the sea, the new oceans literally boiled. Each fresh flow of magma flashed seawater into giant clouds of steam, driving local storms and pumping more heat and volcanic gases back into the atmosphere, even as the planet tried to cool. Along many coasts, entire lines of lava streams fed into the young seas. These repeated encounters between molten rock and water created vast curtains of steam, locally overheating the ocean surface and turning calm stretches of water into temporary boiling cauldrons. Occasional asteroid impacts struck directly into the oceans, instantly vaporizing vast volumes of water. These events blasted steam and debris high into the atmosphere, briefly reversing local cooling and reminding the planet that its path toward stability was anything but smooth. Over time, patches of calmer ocean and thinner clouds began to appear beside regions still dominated by steam, eruptions, and impacts. These scattered cooling windows allowed parts of the surface to stay liquid and more stable, setting the stage for long-lived oceans and, eventually, environments where early life could take hold. By the early Archean, Earth had become a true water world. Vast oceans wrapped around the globe, while only scattered fragments of continental crust rose above sea level, forming the first long-lived islands and protocontinents. Within these oceans, some pieces of crust thickened and stabilized into early cratons, blocks of continental rock, strong enough to survive for billions of years. These plateaus formed the seeds of future continents, providing persistent land where environments could slowly evolve. The atmosphere above these oceans was still very different from today. Carbon dioxide and nitrogen dominated the air, with almost no free oxygen. Yet the climate had become stable enough for long-lived seas and coastlines, creating a stage where new chemical and biological processes could begin to persist. In shallow coastal waters, simple microbial communities may have begun to build layered structures, slowly trapping sediment and altering local chemistry. These stromatolite-like formations mark the quiet beginnings of life's influence on the planet, long before animals or plants appeared. Seen from above, early Archean Earth was a shifting mosaic of oceans and growing continental fragments. Over hundreds of millions of years, these blocks would collide, break, and merge, slowly building the larger continents that would host evolving ecosystems and eventually complex life. From a molten hellscape to a world of oceans and emerging continents, Earth's early journey set the conditions for everything that would follow. In the billions of years ahead, its atmosphere would change, oxygen would rise, and complex life would eventually transform the surface beyond recognition. Thank you for watching.